Welcome to this DevSecOps crash course. After an extremely successful launch of our complete DevSecOps bootcamp, which so many of you were interested in and so many companies are already using to upskill their engineers, after seeing this immense interest in this topic, I wanted to create a DevSecOps crash course for those who want to get an idea of what that is, to get a basic understanding of DevSecOps concepts, DevSecOps tools, and get their very first hands-on experience with actual practical implementation of DevSecOps. So in this crash course, we're going to go through the fundamentals of what DevSecOps is, as well as see some hands-on examples with a demo project. So you get an understanding of it, and then if it spikes your interest, you can decide if you want to actually enroll and do a full DevSecOps bootcamp to learn this extremely demanded skill set and basically just get way ahead in your career. So let's get started. Security is important at all levels of software development lifecycle. In the application itself, the application's runtime environment, and underlying infrastructure, which could be on-premise or cloud platform. And it's important to the level that when companies fail to properly secure things and they get hacked or some data gets leaked, etc., where their user data or company data gets compromised or their systems get attacked and aren't accessible anymore, the price they pay for that is way more expensive than actually implementing the security. And it's expensive both financially, but also reputation-wise. And of course, that means all companies should implement security. However, it is pretty difficult. And there are two biggest challenges companies have in terms of security and what may be the reason why they fail to actually implement the security. First of all, often feature development and providing business value is more incentivized because that's what brings in customers. That's what provides the direct value for users. And very simply, that's what brings in money for the business. So security is like a necessary evil. You don't get so much reward and pat on the back for implementing great security, but if a security incident happens, you get real punishment. So security stays an afterthought in application development or even infrastructure configuration process. The second issue is even if you and your team are dedicated to implementing great security, you still have a challenge because the application systems themselves are becoming more and more complex. Think about the modern tech stack in our application systems. We have a large containerized microservices application that is running in Kubernetes cluster on AWS cloud platform using tons of different AWS services with data persistence in 10 different types of databases. You may have like a primary database, a SQL database, NoSQL database, a caching or memory database, and so on, and tens of external services that your application may be talking to. Additionally, we have a streamlined CI/CD pipeline that deploys to the cluster. Imagine how many entry points and how large of an attack surface such a complex system has that may allow different types of attacks. These levels could be within the application itself, so your own code or third-party applications and libraries that allow for SQL injection, for example, or cross-site scripting or forging requests from clients or even worse from servers. Then you may have security issues within your application container image, like the image operating system layer, the image configuration, all these different third-party operating system packages that you may need in that container environment that may have security vulnerabilities. Now that container will have to run somewhere, like Kubernetes cluster. So here we have the security challenges like, is the access to the cluster security? Is API server publicly accessible or only from within the internal network? Have you opened any unneeded ports on worker nodes that allow access into the cluster nodes directly? Now that's just outside the cluster. What about inside the cluster? Once an attacker is inside, do they have wide open network where thousands of pods can all talk to each other freely? Can the control plane processes be easily accessed from within the cluster? Is the pod-to-pod communication encrypted and so on. Now, Kubernetes is not just floating around on the air, right? It's running on actual infrastructure. Let's say it's a cloud infrastructure on AWS. So now the security continues over to the servers and the underlying infrastructure. Are people able to SSH into the worker nodes directly? If they can do that, they could potentially access the Kubernetes processes on that server directly, or the container processes, or even cloud processes running on those servers. Or what if accesses generally are badly managed? Like permissions are not strict enough and credentials are spread around the company on different platforms and developers' machines, so attacker may easily access them on other internal systems. Continuing with the CI/CD pipeline itself, what about CI/CD accessing your cluster to make deployment updates? What permissions does your CI/CD tool have? Is it able to delete components in all Kubernetes namespaces? So basically, if an attacker hacked into one system like CI/CD platform, will the attacker then get access to credentials stored in your CI/CD platform to your private repositories, Kubernetes cluster, AWS account, basically all the platforms that it connects to? And if yes, what permissions do those credentials have? Are they restricted? Or can they do a lot more damage? And we can go on and on with these security questions around different tools and platforms and so on, with like secret management tools, credential rotation, certificates, and so on. But I think you got the point. Security is complex because the systems have become complex. Security as afterthought means that those potential security issues get analyzed after the main work is done. And there are two problems with this approach. First of all, this creates long iterations and slows down the release process compared to if we checked and found security issues earlier during the development process itself. And second, when you're checking all security at once of 50 new features and bug fixes and 50 configuration changes, you may more easily oversee stuff because you have way more things to test, and more issues may slip into production as a result. Also, naturally, you have high chance of human error when this kind of checks are done manually and less frequently compared to the automated approach. Now, you remember my simplified definition of DevOps. Basically, what it really comes down to eventually is anything, any tool or concept used to remove any bottlenecks on the way of releasing and delivering changes to the end user fast and with minimal bugs. And this applies whether it's application or infrastructure changes. So naturally, if security is a bottleneck in that release process, that should become part of DevOps issue, that we have to eliminate this showstopper. So DevOps naturally should include security, but as I often say, reality and theory, or how it's supposed to be, are two different scenarios. So in practice, it so happened that DevOps left out security. It focused on development and even bug fixes and efficiency and speed in those areas, but security teams and external pen tests stayed in later steps, not streamlined, not automated, and still done mostly manually. So as a reminder to kind of highlight the importance or bring back the importance of security in DevOps, the DevSecOps concept emerged. And as you know, DevOps affects entire software development lifecycle too. So DevSecOps is naturally taking that overarching security and integrating it in all DevOps steps from start to finish, along with application tests, build steps, and so on. So the responsibility of fixing security issues and secure implementation still lies with individual teams and different engineering roles who have the expertise in those specific areas, but DevSecOps creates an overstretching CI/CD process and automated steps that measure what's called the security posture across your systems, basically giving us a visibility of how secure our systems are. So how does DevSecOps do this? Automation is the key here as well, just like it is in DevOps. So with DevSecOps, we automate checking and validating all these layers of security in different parts of the software development lifecycle. and there are tools and technologies to run those automated tests. So what are those automated checks and where in the release pipeline are they added? First, we want to check security of our code. Do we allow for SQL injection because we're sanitizing user input? Are we using weak or outdated encryption algorithms to encrypt user passwords? So all these checks that we're doing in our code to validate for any such security vulnerabilities is called static application security testing, or SAST, where various SAST tools will validate the static code for any of these issues. So it basically scans the code base for known patterns of allowing SQL injection, cross-site scripting, and so on, and common coding mistakes that could lead to such security issues. And in the DevSecOps bootcamp itself, we cover the individual security issue types in detail, so you actually understand what a SQL injection looks like, what it is exactly, what a cross-site scripting is, what client or server-side request forgery is, and so on. And we even learn how to fix some of those issues in code. So instead of just having an abstract idea, just in theory, you actually see hands-on how it looks like and how it can be fixed in the code itself. Now, we also want to check our code for any hard-coded secrets. And this happens way too often that developers forget to remove API keys that they use for testing or hard-coded passwords for database connection maybe. And they basically end up in Git repository, in the commit history, and secret scanning tools can be used to go through the code and identify any hard-coded secrets like access tokens, API keys of various platforms, any credentials, certificates, and so on. Again, in the bootcamp, we go into detail and learn various use cases of when this happen, as well as how to use these tools as pre-commit hooks, so they don't even end up in the code repository commit history because they get validated before the developer can commit the changes. Now, apart from our own code, we also want to check whether the code from other people that we use in our application has any such issues. Like libraries, frameworks that we're using as dependencies, they are code as well, right? That other engineers wrote. So those engineers may also write insecure code just like our engineers. And this is called software composition analysis, or SCA. So we use SCA tools to scan all our application dependencies for any publicly known, already discovered vulnerabilities, and we identify whether we're using any outdated versions of third-party software with security issues. And again, here we have a whole section in the bootcamp where I explain how these publicly known vulnerabilities are documented and where are they accessible, how the SCA tools actually go through these dependencies and identify any issues, how to analyze them once you found that you have such vulnerabilities, and more importantly, how to actually fix those issues. Now, these are all static checks. So we're checking the code base. But there are some security issues that can only be caught when the application is actually running. And this is called dynamic application security testing, or DAST, which is a testing method that basically evaluates a running application to identify different vulnerabilities. Again, this could be SQL injection or manipulating URLs with different parameters to get data that you are not authorized to see. So the DAST tools basically send various requests to the application, and they observe how the application responds, what data it returns to those requests, and this way they can identify any potential security weaknesses in the application. We also want to validate the image artifact that we're producing. Again, there are tools that scan the image layers to find any security issues on the container runtime level. For example, are we using a root user? Are we using a deprecated vulnerable operating system package? Are we using a bloated image with lots of tools that we don't actually need? So we are increasing the attack surface and risk unnecessarily. So there are all these tools out there that help us automate these type of security checks. And again, in DevSecOps Bootcamp, we basically go into details and very importantly, the practical application of introducing and implementing those tools. One of those concepts important in the practical usage of the tools is managing what's called the false positives, as well as how to visualize the scan reports and analyze them in vulnerability management tool, where you basically combine all the reports from different tools and see what issues you have in your application, with what severity levels, where exactly in the application are those issues, and some recommended options of how to fix those. Understanding what's called CWEs and CVEs that are a big part of analyzing and fixing the discovered issues. And also what's very important to me is to reference the real-world projects and understanding wherever relevant whether there is a difference between how the things should work, the theoretical part, and how these tools are actually used in real-life scenarios. Things like how to balance the additional checks that increase the pipeline duration and when to run separate nightly builds for full scans, for example. So I go into detail in these kind of examples in the bootcamp. So these automated security checks are done in multiple phases of release and can start as early as pre-commit, even before the developer has committed the code and the CI/CD pipeline was triggered. So it gives us fast feedback on any security issues we may be introducing in our systems through changes in code or in infrastructure configuration. This is called shifting security to the left, because another important fact is that the later in the release stage we discover security issue, the more expensive it is to fix it. So instead of reactively fixing issues in production and patching them, we are proactively reducing the possibility that they end up in the production in the first place. Now, talking about reactively checking for security issues in your systems, I want to give a shout out to Chef, the sponsor of this video, which is one of the important tools for security and compliance automation as part of DevSecOps. If you've been in DevOps long enough, you probably already know that Chef is a well-established and widely used technology in the industry. Chef Compliance provides packaged CIS benchmark profiles, and these profiles can be easily customized to support your organization's specific security and compliance requirements. You can schedule those compliance scans for single or multiple environments, and you can run them regularly or on demand to basically automatically detect and notify about any configuration drift or errors in your environments. For example, running a profile that checks that 44 controls are set properly and 2 of the controls fail because of a misconfigured kube API server.yaml. To remediate this misconfiguration, Chef can automatically reset the controls to the proper configuration based on the profile. Chef uses the concept of cookbooks, which provide flexible recipes with template and attributes files to specify the correct values for the kube API server YAML. Using a simple chef knife command, we can confirm the managed Kubernetes control plane has the correct cookbook and recipe in the run list. When the chef compliance scan is run again, the Kubernetes system meets all of the necessary requirements. And by the way, the whole Kubernetes security, compliance checks, and CIS benchmarks themselves are super interesting topics, which you also learn with practical use cases in our DevSecOps bootcamp. So as you see, DevSecOps is a huge, exciting topic where on top of the DevOps, which is already a huge thing, you explicitly integrate security implementation in your engineering processes. So large processes, automated. That means lots of tools and concepts involved. So 1 or 2 hours is really just a drop in this large DevSecOps ocean to learn all about it. So I try to take out this part from the entire DevSecOps bootcamp to teach about the fundamentals, and I have carefully created the demo to give you the basics to get started and see the benefits of DevSecOps and get the understanding of how the entire DevSecOps can be implemented in an organization. So now enough with the theory, let's get to the practical part. We're going to be working with one project for the entire demo, and that is an open source project from OS Foundation, which is a Python-based project. And this application is intentionally vulnerable so that it can serve as a demo for various security scans, so we can actually see the security vulnerabilities discovered by those scanning results. So that's the project that we're going to use. Since it is Python specific, we're going to see how to select and then use various scanning tools based on the language or tech stack that an application is using. And in order to work with this project, I actually forked the project and made my own copy. So we can start from a clean state without any scans whatsoever. So I removed all the pipeline code. I made a couple of adjustments and we can build the demo step by step from the start. And I'm going to link both of these repositories in the video description so you can easily follow along. So in this demo, we're going to build a pipeline, a release pipeline that is going to have security checks for this application. So we're going to build a DevSecOps pipeline. And we're going to do that with GitHub Actions since we are on GitHub. If you don't know GitHub Actions, I actually already have a crash course on GitHub Actions, so you can watch this video first to learn the basics and get some foundational knowledge. Of course, I'm going to explain some details as well in this video, but that should give you a starting point. And as I said, I do not have any pipeline code in this project, so we're going to build it from scratch. So here you see we have a tab called Actions. So if I go here, and you actually learn this in the crash course, you have some templates that you can start with. So instead of writing the GitHub Actions file from scratch, you can just go with one of the templates. And templates are based on the tech stack of your application. And as you see, it actually detected what we're using in this application, and it is suggesting us to use either Python template or Docker image template, and so on. And we're actually going to build this pipeline from scratch. However, I still want to show you how the template will look like. So for example, if we choose a continuous integration template with PyLint, since we're going to be building continuous integration pipeline, so CI pipeline actually, and if I click on configure, this will do two things. First one is in my project, it will automatically create a .github folder. So this was not there before. And inside that, it will create workflows folder and then pylint.yaml file. So this path will be automatically created. This is the location where GitHub Actions detects a pipeline code automatically, so it can automatically trigger it and run it. And the second thing is that it generates a boilerplate code for the continuous integration pipeline. And this is what it looks like. Again, if you go through my GitHub Actions tutorial, you will understand the syntax as well. So basically we could take over this template code, but I want to show how to build it from scratch. So first of all, I'm going to rename this to main.yaml. So we're going to build multiple steps in that pipeline. And second of all, I'm just going to mark all of these and just remove. So we're going to start from scratch. And as you learn in the GitHub Actions course, the application release pipeline, whether it's a CI or CI/CD pipeline, is one of the GitHub workflows. That's why we have this workflows folder. We can name our pipeline workflow in our main.yaml file. So I'm going to call it CI. And then we want to configure when this pipeline will get triggered. And we want it to get triggered on push. And you can actually specify which branches you want to trigger this pipeline for. So for example, if I had multiple other branches except for the main, I can say I only want this pipeline to trigger for a list of specific branches, whatever that is. However, because this is a continuous integration pipeline, it makes sense to always run it, no matter whether it's a main branch or feature branch. So that means we can basically say whenever there's a push in the repository, no matter which branch that is, we always want to run this pipeline. And now we can start writing or adding our jobs. And this is going to be a list of security scan jobs that we're going to run against our application. And the first one we're going to be adding is going to be a SAST job. So we're going to run static application security tests on our Python application. So let's call it SAST scan. And we're going to use a tool called Bandit, which is a popular tool specifically for Python applications to run static application security tests. Now, as you know already, I always repeat that the tools are not as necessary as knowing the concepts. So you could theoretically use whatever tool you want. However, of course, when you compare the tools and evaluate them, you have to consider a couple of criteria. So first of all, the adoption, right? If it's largely used by a community, there are a lot of people who are contributing to this project. If it's an open source project, for example, then that is definitely a plus for the project, because you don't want to be one of the few engineers who is using a tool that nobody else is using or knows about. Another one is, of course, how easy it is to integrate, to use the tool. Is there a ready official Docker image for the tool? So basically, this simple criteria should be enough to decide what tool to use, because beyond that, like the specific features and so on, do not matter as much, because most of the tools are pretty similar. They can be configured in a very similar way. So for most common use cases, they should work pretty much the same. So Bandit is a very popular tool for Python specifically, and it's also pretty easy to use. And that's why I chose that one. But again, you can choose whatever you want. You can also choose multiple tools for the same job. So you can actually have 2-3 different tools that do SAST scanning, and basically you can compare the results and see maybe one of the tools finds vulnerabilities that others were not able to detect. That is a common practice as well. So let's go ahead and write our script to use Bandit. Again, you learn in the course that within a job you have multiple steps or actions that you want to execute during the job. So let's configure all those steps. So first of all, let's add a description or name. We're running Bandit scan. We also want to specify that we want to run it on an Ubuntu machine, because then the installation of the tool, etc., will depend on which operating system we are executing the job or the steps on. So we want an Ubuntu runtime environment for our job. And now we can write those steps. We're going to start by checking out the code, obviously. So again, as you learn in the course, the jobs get executed on fresh new environments on GitHub's hosted machines, and you can choose what operating system that machine should have. And that means it's a fresh new machine. It doesn't know anything about your application. It doesn't have any tools that you need pre-installed on them. So you have to explicitly install things on it, plus check out your application code so you have that available. And obviously we want to scan our application code, so we want to have the code on that machine where the job is going to execute. So check out the code, and we're going to use an action here called checkout version 2. And this will take care of checking out our repository code. The second step will be to set up Python on this job environment. As I said, no tools are pre-installed, so we have to explicitly install anything that we need for the job. And we need Python because Bandit is a Python package, so we're going to install it using Python's package manager called pip. So we have to install Python first, or basically prepare the Python installation and setup. And again, for this kind of common regular use cases, there are actions. So we're going to use one of those actions that is called setup Python with this version for the action. And we can specify a version of the Python that we want to set up, use, which is logical because whenever we are installing a tool, obviously we want to have an option to specify which version of the tool we want, right? So we're going to define Python version 3.8. That's the version we want to use. And by the way, you can find those actions here as well to see what attributes and parameters you can use. So if I search for setup Python, there you go. This is the action. And you can see all the attributes that you can set here. So Python installation is done here. Now we want to actually install Bandit so we can execute the Bandit scan, right? So as I said, it's a Python package. So we're going to install it with Python's package manager. So it's going to be install Bandit. And for this, we're going to actually run a command directly on our Ubuntu machine where the job is executed using pip install Bandit command. Super easy and straightforward, right? And finally, we want to run the Bandit command or Bandit scan with a command called bandit -r dot. So this basically scans everything in the current folder. So this is a location where we're pointing bandit to. We're saying everything in this current folder, all the files that it contains should be scanned recursively. So whatever folders we have here, subfolders that contain Python files, all of that should be scanned. Very simple and straightforward, as you see. And the folders or the code that we have available has been checked out with the first step. So that means the application code will be on the machine. And after installing Bandit, we can just run Bandit scan against that entire application code. So it will check and scan every single file in the application code and give us the results. And this is how you set up and run a security scan. And now we want to commit those changes. And as I said, because we have this YAML file in GitHub or .github/workflows folder, GitHub will automatically detect this location and it will know there is a workflow to automatically execute on code push. So this will trigger our SAST scan job. So let's do that, commit the change. I'm gonna work directly in the main branch for simplicity, for our demo. So let's go ahead and do that. And if I switch to actions, as you see, the workflow is already running. It's in progress. So let's wait for its execution. So run bandit scan job was executed. And if I go inside, we're gonna see the execution results. And as you see, the job failed. And that is good because it means the bandit scan actually found security vulnerabilities in our Python application and it failed the job, marking our application as not releasable, which is the purpose of security scans, right? So let's go ahead and check out the results. And right here in the run bandit scan logs, you see the test results listed with some detailed information. If I scroll all the way down, you see all those are possible security issues that it detected. And right here we have a summary that says how many lines of code it scanned and how many issues it detected. And one helpful thing that the tool also gives us is it doesn't only tell us, hey, there's a security issue or possible security issue here, but it also marks it with the severity level because not all issues are equally important or equally risky. And that's why we need to differentiate between them. So we have the severity level that basically says these are some issues, but they're low severity, so they won't cause as much damage. And they are high severity issues, so this could be a more risky, highly exploitable security issue. And this is an important metadata about the findings because as you see, we have way more low severity issues than high severity issues. And in practice, this creates a lot of noise and distraction from the actual severe issues. So usually in DevSecOps, we want to configure the scanning tools to only focus on high severity or medium severity issues, especially when we are first introducing the scans to the team. Because imagine we're going to the developers and saying, now we're going to start scanning the application, and if there are any security issues, you have to fix them. And the tool finds hundreds of security issues, most of them low severity level. So developers don't have much value from the scan and they don't know how to handle these hundreds of security issues, right? So this may create a lot of unneeded effort and just distraction without bringing much value to the team. You won't be too popular with developers if you do that. Instead, if you show, hey, we ran this and it detected 2 severe issues, that's manageable for the developer team and proves the usefulness of the scan to the developers that aren't fully bought in the DevSecOps concept yet. And the tools can be tweaked to teach them or to configure them to only focus on what's important and mature those tools to the level that we 100% can rely on their findings. Another metadata that we are getting here along with the severity level is confidence. So confidence is basically the tool's level of confidence about the discovery itself. So it found a high issue with low confidence. It means it may be an issue, but the tool itself is not 100% sure that it detected the issue properly. So it could be a false positive. So for example, here we have an issue that is medium severity, but the confidence is low, which means the tool is not actually confident that the issue is an actual issue with medium severity. So that could be a false positive. And as I said, we can configure the tool to ignore everything that is low severity or low confidence and just concentrate on the important findings. And all security scanning tools have that configuration option. As I said, most of them work in a similar way. So let's configure Bandit to ignore and not display any low severity issues, as well as issues with low confidence. And for all these tools, of course, you have the official documentation pages where you can see the command options and how to tweak and configure those tools to your specific needs for your application. And right here, as you see, it has an option to configure what level of severity we want to focus on and what confidence level we want to focus on, and let the tool ignore anything else. So we're going to use these options to tweak our Bandit configuration. So going back to the repository, this is our workflows folder, and let's edit our Bandit command with this configuration. So basically, we're going to tell Bandit to only focus on medium and high level issues and only medium and high confidence findings. So we're going to add those two options. So I'm going to copy them, add them here, take this one, and that's it, basically. That's the configuration. Let's commit the changes again. Let the pipeline run. The Bandit scan failed again. However, now let's see how many issues it actually printed out. So the summary stays the same. So we get the information about how many issues we have. However, the logs themselves, as you see, we only have medium and high severity issues with high or medium confidence, right? So our list of findings have decreased, which means this is more manageable for the developers now. So they can actually go through this and analyze those issues one by one because they're just a handful of them. And again, if you're just starting out, so this is the very first introduction of DevSecOps tools to your project team, you can even start with only high severity issues. And once you have those fixed, then move on to medium findings. As a next step, we're going to configure our Bandit scan to produce a reports file and to provide all the findings of the scans in the reports file instead of just displaying them in the job logs. Again, we can find that configuration here. We have two options for that. First of all is the output file. So that's going to be the name of the report file. We can name it whatever we want. And the second one is the format of that report. So you can produce reports in multiple formats. This could be CSV, HTML, JSON, XML, whatever. And note that all of these formats are meant for machine consumption and not human consumption, which means there are actually tools where you can upload these scanning reports where you can visualize in a nice UI and analyze your findings there in one place. And I'm going to explain that in detail later in the demo. But for now, let's produce those reports. So we have the findings in the reports file. So we're going to export it in JSON format. So let's go ahead and do that. It's going to be F or format JSON. And we're going to produce an output or output file. And let's call this bandit report.json. And as I said, the purpose of generating a report file is so that we can take that reports file that has the findings inside and we can feed it or upload it to a vulnerability management tool such as Defect Dojo that will then consume that file and display all the contents of it in a nice UI and a nice list with all the information about the finding, the description, the fix recommendations, and so on, whatever the tool basically provides, which makes the analyzing and fixing of those issues way easier. And as I said, if you run the pipeline multiple times a day, if you have multiple tools, you have to have a central place where you can view and manage all those findings, or the team of developers can view all those findings in one place, as well as compare the findings between the pipeline runs in a vulnerability management tool because you can't manage them through the logs. So this is a very essential, very important part, how to upload reports and how to consume them, how to analyze those issues in Defect Dojo, which is one of the most popular vulnerability management tools for DevSecOps. And you learn all of these in the DevSecOps Bootcamp. So right now, we are generating the report. However, to make it possible to download that report, we have to create an artifact or the job artifact that will be uploaded for the pipeline at the end of the pipeline execution. And for that, we want to have another step to upload that artifact and make it available for download for us. So let's call this upload artifact. And there is an action for that, of course, because it's a very common use case or common step. It's called upload artifact. Again, you can check what the latest version is. And we can provide the name of the artifact. So how it should be called when it's exported. Let's call it bandit findings. And of course, we need to tell it which artifact to export. Now, as I said, the jobs in GitHub Actions run on isolated fresh new machines that spin up for that specific job. All the steps get executed there on that machine. And when the job is done, the machine gets thrown away. Everything that we generated there, including the reports file, everything is gone, right? So that means with upload artifact, we're taking the file that we generated on that machine that's going to be thrown away after the job is done. And we're going to say, yeah, take that file and upload it as an artifact so we can have it available after the pipeline has run. So even when the machine is gone, we still have that file available. So the path points to the actual file or folder on that machine. And this is just what we want to call it. And they will make this file available after the pipeline run. However, there is one more thing we need to do for this to work, which is the way GitHub Actions works is that whenever any step in the job fails, the next steps will be skipped, right? So for example, if the Python installation didn't go through because of whatever reason, or the bandit installation, so this command failed, the next steps will be skipped, which makes sense because usually this is an order of executing the tasks where the next step kind of relies on the previous one. And that means when the bandit command fails, which it will fail because we have security issues in the job, this will not get executed. However, we want the findings or the reports file to be uploaded with those findings. So even if it fails. And that means we have to explicitly tell GitHub to execute this step always, which means whether the previous step fails or succeeds, it doesn't matter. Always execute this last step. So let's commit this. And now when the pipeline runs, we should have the bandit report.json file available there. So let's go back to actions. There you go. So the job failed. And if I scroll down here, you see the artifact section. And now we have this bandit findings artifact. I can show that it was not available for the other jobs. So here we don't have the artifacts. And this is the JSON file. So in the zip file, there is bandit report.json file. And here we have all the information about those findings, additionally to what's displayed in the logs. So that's how it looks like. As I said, this is for machine consumption or for those vulnerability management tools where you can upload the reports file and you can display those results in a UI. Awesome. So we have scanning for our application code using Bandit, which does SAST scanning, but we also learned that not only the application code or the dependency code, but also the application runtime environment may have security vulnerabilities that will allow the hackers to hack into our systems. And since in the modern application development, Docker and containers have become a standard, the artifacts that we are producing in our release pipelines is Docker images. And Docker image, as you have probably already learned from my Docker videos, you know that it's built with layers. So every single image layer may actually have a security vulnerability. And image layers, just as a reminder, are basically whenever we're using a base image, could be a Linux Alpine base image, which is a lightweight operating system layer. And then on top of that, we install a bunch of other stuff like Python for our Python application image, or various operating system packages and tools. All of that basically add as layers on top of each other. And just like in application code, we have libraries and dependencies with vulnerabilities. We may have operating system packages and software with vulnerabilities. So we may actually be using outdated images like base images or operating system tools with security issues. And the same way, we want to scan the image to understand how secure is the Docker image that we are building for our application. And we have various tools for scanning Docker images. And in this demo, I actually chose a Docker native tool that actually part of Docker itself that is called Docker Scout, that goes through the image layers and scans for security issues. And it does that actually on multiple levels. So let's add a job for Docker Scout and see how vulnerable or how secure our Docker image is. And of course, to be able to scan a Docker image, we need to first build a Docker image. So we're gonna extend our current CI pipeline to build the Docker image, and then we're gonna scan that newly built Docker image. So let's go ahead and do that. So right here, we're gonna add a new job, and this job will contain the steps for building the image and then scanning that image. Now this could be two separate jobs. So for example, we can push that image to a Docker repository, and in a separate job, we can pull that image from the repository and scan it. However, to make this simpler, we're gonna have one job where the image is built on that job execution machine. So we have the image available, we don't have to pull it from anywhere, and then on the same machine, we're gonna run scans against that image. So I'm gonna call this job image scan. And I can actually just copy this configuration from here. Let's call this build image and run image scan. We're gonna run on Ubuntu latest. And here we're gonna define our steps. The first one is again gonna be checkout, because we need our application code with the Docker file to build the Docker image. So we have the checkout step. Now, for this job, we actually don't need Python. Instead, we need Docker installed on the machine where the job is executing, because we're going to execute Docker build command to build the image and later Docker scout command. So the same way we set up Python in this machine for this job, here we're going to set up Docker. So let's create a step. Let's call it setup Docker. And let's actually search our marketplace for the action to install Docker. So I'm going to look for setup Docker and let's see what comes out. And we have this one here. This is the location of the action. So I'm basically just going to copy that and paste it here. And as I said, for any actions or any steps that are very common, like installing Python or Docker, they are pre-packaged or ready actions that you can just reference from the marketplace, which just makes the creation of the pipeline easier. But of course, alternatively, you can just run a command for installing Docker as well. I prefer to use this action for the setups, just easier, cleaner code, especially if something changes in the installation of the tool. You don't have to worry about that. And then, of course, you have these parameters that allows you to specify additional stuff. So for example, I want to define Docker version for our installation, and I'm going to do that with the with attribute. And this is the Docker version. And I'm going to set it to one of the latest Docker versions. Let's do 20.10.7. And that makes Docker available on our job environment, which means we can now execute Docker commands. And the first command will be to build the image. And for that, we're going to simply run Docker build command. And you know the drill, we need to specify the Docker file as a blueprint for building the image. We can also specify the name of the image so we can reference it later when we want to scan the image. So we can call this myapp or pygoat or whatever, and we can tag it with the latest tag. And then we have to specify the build context, which is the location that Docker will take as a build context. And this is going to be the current directory where the application code is, and that's our Docker build command. Awesome. The next step will be to scan that build image for any security issues. And as I said, we're going to use Docker Scout from Docker itself, which actually does a very thorough scanning of the images on multiple layers to find any security issues. And we can actually use two different commands of Docker Scout. One of them is called Quick View. Quick View command will basically show you that your base image is outdated, and it will give you a recommendation of how to update it to make your image more secure. And then there is a more extensive or more thorough scanning that you can do with Docker Scout CVEs command. It basically gives you a complete view of all the vulnerabilities that your image contains. And just like the other tools that we've used, you can tweak it and configure it to add additional flags to basically limit that you're only interested in certain severity level and so on. So let's go ahead and add a step for Docker Scout commands. So we're going to add a step here. Let's call this Docker Scout scan. And we're going to run a command here that basically is a multi-line command. And this syntax basically allows us to write multiple commands, one after another, instead of just a single command. And here we're going to first install the Docker Scout command line tool, and then we're going to execute Docker Scout commands. And I'm going to copy the URL, which points to the installation. So this will basically download the installer for Docker Scout CLI. So install scout.sh file will be created locally. Then we can execute that installer file, that shell script, to actually install Docker Scout. And here we can then execute Docker Scout commands. As I said, we can use both commands for a quick view, as well as to scan the complete image for any vulnerabilities. So this is actually the main command that scans the image, and that's what we are executing. Now let's actually try to run this and see what happens. So I'm going to commit the changes, and let's actually see the execution result. Again, you see that by default, these two jobs will actually be executed on two different machines. That saves time because these jobs can be executed in parallel instead of waiting for the previous jobs to execute. So your pipeline is overall faster. So the job is running. Let's wait for that. The image is being built. And we can also check the Docker file. So this is a pretty simple Docker file actually. We just have a couple of commands. So each one of those commands basically creates a new layer, and we may be configuring the Docker environment or installing tools that are vulnerable because they're outdated, and those things will be scanned with the scanning tool. And the Docker Scout scan failed, and you see the reason for that is because we need to log in to Docker to execute Docker Scout. So we need to authenticate with a Docker ID and email address. So that's what we need to set to authenticate with Docker so we can execute Docker Scout commands. And that leads to another interesting concept in GitHub Actions, which is project secrets or project environment variables that you can use to basically store secret or sensitive data. As you know, in release pipelines, CI pipeline or CI/CD pipeline, you have to integrate with multiple tools, right? So you are maybe pushing to a Docker registry, maybe you are deploying to an AWS environment, and you have to connect to these platforms with credentials, right? So you need a proper way of storing those credentials, and obviously you don't want to hard code them in the code, right? So in the settings of the project, you have security section, and in that security section, you have secrets and variables. So if I open that and open actions, so these are where you can create secrets and variables for GitHub Actions workflows. And we're going to create a new repository secret. So basically, whatever secrets and variables we create here will be available as environment variables in the GitHub workflows. So you may have multiple workflows for GitHub Actions, and you can use these secret values or variables in all your workflows. So here I'm going to create variables, secret variables for my Docker user and Docker password. So basically, these are the ones that I use to log into Docker Hub. So if you don't have an account, you can just sign up here and you get your Docker ID and Docker password. And I'm going to call these repo user. You can call these whatever you want. And this is my Docker ID. And now I'm going to create repo password and with the value of my Docker password. So those two values are here, which means I can now reference them in the pipeline or in my workflow. So going back, let's edit. So before we execute the Docker Scout commands, we need to first log in to Docker. And you probably already know Docker login command from various of my previous tutorials where I have showed this. So a safer login is not to provide password directly with password flag, but rather read it from the command line. So we're going to do echo and our password variable. And the syntax for referencing environment variables or project variables, repository secrets or repository variables in GitHub Actions is very simply $ and double curly braces like this. And inside that you have secrets object that contains all the secrets that you have defined here. Like this. So this is referencing the value of the password. And then we are piping that to Docker login command. So we have the username, which again, we're going to reference like this. Repo user. And we're going to read this password using password stdin, standard input. So this is going to read whatever we echoed here. And that's it. We don't have to provide the repository for Docker login because by default it is Docker or docker.io. So this login command will automatically go to Docker itself. And that's it. We're authenticating with Docker. And after that, we can execute Docker Scout commands. So now we're going to commit those changes and we're going to see the results of Docker image scan. Our pipeline ran. So now let's actually check the logs to see the findings. First of all, you see that the job is green. Let's see what it means. So we have the build Docker image, a new image was built, and then we have Docker Scout results. This is the login part, and this is basically an output of Docker Scout quick view command, which basically gives you an overview of what image you're using, what is the base image that we have defined in our Docker file that we're building on top of. And then it also tells us whether our base image is outdated, the size of the image. As you know from security best practices of Docker, we don't want to use bloated, unnecessarily large images because it just increases the attack surface unnecessarily, especially if we don't use or if we don't need most of the tools in that image for our application and so on. So this is like a quick overview. And this is a more detailed overview of analyzing the image. And this is the Docker Scout CVEs command. And here you see a whole list of the things it found, which are a lot of issues. So basically, for different tools that we are installing or using in our Docker image, for example, this one here, the curl package, or this package with this specific version have all these vulnerabilities. And this is actually similar to the dependency scan because just like you have libraries in your code that have dependencies on other libraries and so on, so you have these transient dependencies, here we have a couple of tools that we're installing. However, since we're using this as a base image, which depends on another base image that has some tools installed, Docker Scout basically goes through all these image layers, including whatever base image this one is built on, and it looks at the tools that not only the tools that we're installing on top of this image, but also whatever tools this image itself comes with. And that's why we have so many issues here. We have a pretty large list of vulnerabilities that it found because it basically went through multiple layers all the way to the initial image. And we can actually check that ourselves as well. So if we look for a Python image in Docker Hub, so this is the official Python image, and in text, we basically look for this tag specifically. This one right here. As you see, Docker Hub itself shows you these vulnerability scan results for the base image. And this one is also supported by Docker Scout. And here you see the exact breakdown of which packages in this specific image are included and what vulnerabilities those packages actually have. And as you see, we have curl, Python, OpenSSL, all of these are basically part of this. And the thing is, if we don't need curl, for example, or Git in that image, then there's no need to use this larger image as a base. Instead, we can use a slimmer, lightweight image with less libraries. And less libraries automatically means less risk for finding vulnerabilities, right? And this is a Docker file that is used to create this image that installs all those tools and so on. And again, you have this differentiation with critical, high level, medium, and low severity vulnerabilities. So you can kind of prioritize and see if you have critical issues, which libraries are affected by those critical issues, and so on. So that's one thing, using just smaller images. But also, this is one of the older versions. The new version is already at 3.13. So of course, upgrading to a new version often would mean that some of those issues and vulnerabilities were actually fixed, but you can also introduce new ones. So we're not going to go into the remediation part, but this kind of scan basically gives you a really good overview of whether you are using an outdated image or whether your image is too large. So you have lots of libraries and packages inside, which also have vulnerabilities. So you end up with a huge list of security issues in your Docker image scan. And also, as we saw, we have this severity level for each security finding. And we have 23 critical issues and 267 low-level issues or low severity issues, which means, again, this creates a lot of noise. Look how large the list is. That means, especially at the beginning, when it's the first time running an image scan for your application, your engineers probably don't want to deal with, in this case, hundreds and hundreds of vulnerabilities and just, fix them. So you can focus on the critical and high ones and then basically step by step move on to the less critical ones. So in this case, again, it makes sense to configure Docker Scout command to only print out those two severity level issues and basically ignore the other ones. And as you see here, you can even use the Docker Scout recommendations command to give you suggestions of how to fix those issues that were discovered. And one more interesting thing that I want to draw your attention to is that for the issues that are discovered, so for example, this one right here, apart from the CVE link, you also have the fixed version attribute. So it tells you which version you're using, which is less than or smaller than this version. And it tells you that there is a version that has this vulnerability fixed already. So you can upgrade to that one to basically get rid of this security issue. And you also see that for some issues, the fix has not been done yet. So there is no safer version for that for now. But again, many of these apply to the low severity issues, which means we can now go back to our workflow and configure Docker Scout to basically just ignore all of those. So we don't have this overwhelming list of issues, but we can kind of filter out and just focus on the real issues and have them in the logs. However, before we add these configuration options directly here, I want to show you an alternative option of running Docker Scout commands with a ready GitHub action from the marketplace. And this is another good example to show using the ready actions from the marketplace. And of course, the main advantage of using actions from here is always that it's high level, it's more abstract, and it's just easier to configure than directly working with the tool. Less flexible sometimes, but if you just want to run the tool with a couple of parameters and configuration, it's basically the easiest way to get started. And if I look for Docker Scout, you'll actually see that there is one from Docker itself. So this is an official action, which is always good to use the official ones. Now, obviously the installation of Docker Scout itself was pretty simple, as well as running the Docker Scout commands. So there is no requirement or need to use action instead for simplicity, because it's pretty simple already. But generally speaking, these ready actions make it easier to use any tool with a high-level configuration, so you don't have to worry about installing the tool, making sure that this curl link is up to date and so on. So I just want to switch to this one for demonstration. But to make sure you guys still see this code snippet in the repository, when you follow along the demo, I'm actually just going to comment this out. And I'm just going to create a new step. And this is going to use the action. There you go. So this is Docker Scout action with this version. And then we have a couple of configuration options. Obviously, we need to configure the login data just like we did here. So for that, we have Docker Hub user and Docker Hub password. So we're going to do with, and then we're going to set all those parameters that we need. So Docker Hub user is going to be referenced like this. Then we have Docker Hub password. And I'm just copying this stuff so that I don't make any spelling mistake. There you go. So we have the login data. And finally, we have the command, because we actually have to execute some kind of command. And this is a list of commands. So we can basically execute multiple Docker Scout commands. We just need 2 of them. So I'm just going to list them here like this, separated by comma. And that's it. So this is basically exactly the same as this part here. Looks a little bit cleaner, nicer. That's the only difference in terms of what they do. However, when I execute this, we will actually see one more difference of using this action instead of running the Docker Scout commands like this, which is an improvement. So let's commit the changes and let's wait for the job execution. Okay, so our pipeline executed. So this is the one with Docker Scout action, and this is without. And let's compare those two. So this is the workflow with Docker Scout action, and this is without. So if I scroll down here, we basically have our artifacts and some information like annotations. And when we execute it, the build image and scan image with the official Docker Scout action, if I scroll down, we see this visualization of results in the user interface view itself. So instead of having to go and check the logs, we can basically see the entire thing here. We see the breakdown of what libraries got scanned, how many critical, high, etc. issues each library had, as well as the base image and total summary of the entire image scan, which is actually pretty nice because this makes it way easier to analyze and kind of dig into your image and what libraries you're using and what you may need to update to fix those issues and so on. So for example, you see all these libraries actually do not have any critical issues, so you can just ignore them, etc. So it gives you this nice overview. So that could be another advantage of using this Scout action. And finally, with that configuration, let's now tweak our Docker Scout action to only report critical and high-level issues. And also, in addition to that, we want to create this report file that we have generated for other tools. So let's do those 2 changes. I'm going to edit this again. And again, if we check out the official documentation to see what configuration options we have, but this time for the Scout action itself. And again, if I bring up the Scout action, we're going to see all the configuration options here. However, if you want, for example, a more detailed overview with examples and so on, we can also search it online. So this GitHub repository, for example, that has Scout action gives you a more detailed description of the inputs 4 different comments. So this one, for example. And as I said, we only want to focus on certain level of severities. And this is the option to configure that. So we have only severities, and we can basically just choose or provide a comma-separated list of what severity levels we want to focus on. So I'm going to copy this and edit here as a parameter. And I'm going to choose critical and high. So that takes care of ignoring all the low and medium level issues. And we also want to configure the report file, and we have this sorry file, which is a specific format. And again, if I check this here, it basically expects a file name. So we can set this parameter as well. And we can call this scout report dot serif. And of course, we have to upload that artifact as well so that it's available after the workflow runs. And let's call these Docker Scout findings. And of course, the name of the report. And that's our configuration. Now with this, we're going to commit the changes and run the workflow again. And now, after this configuration, we see in the scan results that only critical and high-level vulnerabilities were displayed by the tool. And in the list of libraries that were scanned, we see that only those that have either critical or high vulnerabilities are displayed here. So we don't have this huge list anymore, but we have rather manageable list right now. So we can even limit that only to critical issues. So we would basically be working on fixing and updating these libraries here. And again, we still see the overview on all levels of severity issues, including low and medium. However, the specific issues are only limited to those 2. So it's not overwhelming anymore. And additionally, we also have these Docker Scout findings, which were exported as an artifact. And again, we can download it and import it in a vulnerability management tool along with other reports. And one more optimization we can do with Docker Scout is to basically fail the job when security vulnerabilities are found. And again, if we go back to the documentation, we see there is this exit code parameter that is by default set to false. And we can set this exit code to non-zero value, which will be unsuccessful or error result, which will fail the job. So again, let's adjust our configuration. And instead of default false, I'm going to set it to true. And let's commit the change. And wait for the result. And if we check our pipeline run, you see that our image scan job is also red because we have security issue findings in the result. So we optimized that as well. Awesome. So our pipeline is doing all the static code checks, is scanning the image artifact that we are building for any vulnerabilities. And we're producing these 2 different scan reports. And when you're implementing DevSecOps in your organization, you have to use vulnerability management tools because otherwise it will be really inconvenient and hard to analyze and fix the security issues, or to basically just see the security posture of your application and of your systems based on the security scans that you're doing. So you're kind of unnecessarily making your work harder. And as I said, there are different vulnerability management tools. One of the popular ones, which is an open source project, is Defect Dojo, which is the tool I teach in the DevSecOps Bootcamp. And of course, every time we run this workflow, it will produce new reports. That means you don't want to be manually downloading these reports from each workflow execution and then importing that manually in Defect Dojo either. You want to automate that process because it just happens too often and it's a repetitive task. So in the DevOps Bootcamp, of course, we want to learn things as they are done in production in a proper way. So I actually show how to write a Python automation script that takes the reports from each pipeline execution and automatically connects to the Defect Dojo API and automatically uploads and imports those reports in the Defect Dojo. And again, you can group that per application version So you have a history of scan results and see whether your issues are increasing over time, or as you are fixing the issues, are they decreasing and getting less over time. The second important point is, now that we've discovered the issues, those issues need to be fixed, right? So first of all, who fixes those security issues? Is it a DevSecOps engineer? Is it a DevOps engineer, security engineer, the application team itself? So who is responsible for fixing the issues in the code, fixing the issues in the libraries, or upgrading the library versions so we don't use vulnerable, unsafe, or insecure libraries? Who fixes the Docker image issues? And so on. And this is important to understand, to know how DevSecOps is implemented, how the responsibilities are divided among the team members in a practical, actual real-time project. So in the DevSecOps Bootcamp, we go into the topic of dividing the roles and responsibilities with DevSecOps principles, and also how to pragmatically approach this in an organization to implement DevSecOps and involve all of these other roles in the implementation process as well, and to kind of motivate them to join in and not kind of resist against it. What's also super important is we see different issue types like SQL injection, vulnerable code, vulnerable third-party libraries, and how to fix those, including the transient dependencies. Same with the Docker image scanning, how to fix security issues found in your Docker image. And here it's important to understand the CVEs in dependency scanning and image scanning. So we go into detail in all of those areas and learn how to analyze and find such issues, and then, of course, fix those issues. And we actually use completely different project and completely different application in the bootcamp. So this Python application on GitHub Actions is just to demonstrate the basic principles in DevSecOps. So we are actually not repeating anything from this crash course in the DevSecOps Bootcamp. So this should already give you a pretty good basis and understanding of DevSecOps, so you can actually go ahead and start implementing this already. However, you may want to know what the next steps would be that DevSecOps also encompasses, and also more advanced scenarios, diving deeper, and really getting to the production grade DevSecOps processes. So of course, the obvious one is that the continuous deployment part comes after that, where deploying to servers on an infrastructure will open up another world of security concepts like cloud security, infrastructure security, server administration, secure deployment to the servers, and so on. And as you know, in today's world, no DevOps topic is complete without Kubernetes, which again is its own separate world of various different concepts that are security relevant and security related. So starting from security handling, data encryption, network security within the Kubernetes cluster, access control management, and DevOps and DevSecOps is anyways about automation. So policy as code, cloud infrastructure as code, compliance as code, and so on. So there's a ton of concepts and tools and topics involved in DevSecOps that takes this whole thing to completely new next level. And that's exactly why we have a complete bootcamp to teach you all of this, because it's a huge subject. It's a very interesting but very complex skill set. So you need a proper guide with easy explanations, with real life production use cases and examples to become really good at this subject. So all these advanced topics, plus the monitoring and logging on cloud level, on application level, on Kubernetes cluster level, for security specifically. So all of that is in the bootcamp. That means if you need this for your career, for your position, or if you work at a company and your company or your projects actually need this, then DevSecOps Bootcamp that we created gives you complete picture and complete skill set of everything you need to learn and know about DevSecOps. We worked on this for almost 2 years, and there is way more content, and the topics and projects are way more comprehensive than anything that you can find out there. So as I said, if this is a topic of interest for you, then I definitely recommend our DevSecOps Bootcamp as a next step to completely uplevel your career for just a fraction of the price of what an engineer with this skill set will earn. So definitely check out the information about the bootcamp in the video description. But if you just needed to get the conceptual understanding of DevSecOps, understand what it is, and get your first practical experience with DevSecOps, then I hope I was able to give you exactly that. And this will help you in your job, in your project. I'll be very happy about that as well. And if it did, please let me know in the comments what you liked about this, what value you got out of this, and as well as share it with other engineers who you think will also benefit from this knowledge. And with that, thank you for watching till the end, and see you in the next video.